Hello, welcome to the YouTube channel Effectual Learning. Today, we take an in-depth look into electromagnetic induction and AC generator in the 3D interactive page hosted at the website effectual.github.io. Here, you can visualize the basic working principles behind alternating current generator and understand the laws associated with electromagnetic induction with the user interface tools available there. You can find the page under the topic Magnetism. The link for the web page is given in the description for this video. Induction of current in the loop of coil can be explained by understanding Faraday's law of induction and Lenz law. When a bar magnet is moved inside a solenoid, we observe a deflection in the galvanometer needle connected to the circuit. If the bar magnet is rotated, the poles north and south gets flipped. On moving the bar magnet again inside the solenoid coil, galvanometer needle deflects in the opposite direction. This indicates that a change in the magnetic field lines linked with the solenoid coil induces a current in the wire. If the magnetic field lines linked with the coil remains unchanged, no current is induced in the coil. Usually, change in magnetic field lines or flux linked with the coil are accomplished by using another solenoid as an electromagnet. This solenoid is known as the primary coil, and the solenoid in which current is induced is known as the secondary coil. A varying current in the primary coil induces current in the secondary coil. No current is induced in the secondary coil for a steady flow of current. Current induced in the secondary coil is reversed if the polarity of current is flipped in the primary coil. This phenomena can be explained using Lenz law, which states that induced current in the secondary coil is such that it tries to oppose the change that causes it. In an AC generator, the armature coil is rotated at a high speed inside a strong magnetic field, usually an electromagnet, converting the mechanical energy into electrical energy. Sources of mechanical energy for the armature rotation include steam turbines, water turbines, internal combustion engines, wind turbines, etc. When the armature coil is rotated in uniform magnetic field, current is induced in the coil. The amplitude of the induced current depends on 1. The number of coils, 2. The magnetic field linked with the armature coil, or the magnetic flux defined as the strength of the magnetic field multiplied by the area of the armature loop. The direction of the induced current in the coil is given by Fleming's right-hand rule. The thumb, forefinger, and the second finger of the right hand is stretched out at 90 degrees to each other. Here, the thumb points in the direction of the mechanical force. The forefinger points in the magnetic field direction, north to south. Then, the direction in which the second finger points gives the direction of the induced current in the coil. Also, here you see the red pointer represents the mechanical force direction, the blue pointer represents the magnetic field direction, and the green pointer gives the direction of the induced current. Every half cycle, the direction of the current in the coil is reversed. Maximum current is generated when the coil is perpendicular to the magnetic field, that is, maximum field enclosed within the armature loop, and 0 when parallel to the magnetic field lines. The magnitude of the current induced in the current circuit varies as a sinusoidal function. Similar to electric motor, the wire loop is connected to the external circuit by means of split rings and carbon brushes. When the coil is rotated with constant speed, every half cycle the current induced gets reversed, resulting in an alternative current to flow through the external circuit. These demonstrations about laws and tools associated with magnetism allows the user to visualize the invisible forces, which makes them almost better than the real thing to understand the basic working principles. Visit the website effectual.github.io for Physics 3D interactive simulations and see the effect of visual learning.